Good morning, everyone. My name's Grant. I'm going to be the session chair for the next few sessions. I just wanted to kick off by acknowledging the traditional custodians of the land on which we meet today, the Gadigal people of the Eora Nation, and pay my respects to their elders past, present and future. This morning, the first session, we've got Ishaan to talk to us about writing perfect code, which I've already heard a few people joking about, is there such a thing? One of the focal points of his talk is going to be the around VS Code, and even when I was writing Microsoft applications, I didn't use Microsoft products, but I've found myself using VS Code more recently, and it's an interesting tool, but I find that some of the Python integrations are a little opaque and hard to wrap your head around. In fact, sometimes the only time I get them to come up is when I accidentally hit the key combination that gives me a terminal. I don't know how I got there. So I'm really looking forward to today's talk to find out actually how I might use that more productively and constructively. So I'm going to hand over to Ishaan and enjoy the talk.
Thank you, Grant. Welcome, everyone. Let me just get my bearings. So hello. This talk is very live code heavy. So I would like to, I want the demo gods to look down on me for this. And also, interestingly, out of my 4 previous employees and the current one, there's a representation of 3 of them. So 3 out of 4 of them are here. So I think that's, I think it just shows that I'm very clean to Python, maybe. Anyway, so this is my talk. I'm Ishaan, I work at BVN. And I apologize about the clickbaity title. I think a more appropriate title would probably be, watch this talk and it'll make you a maths genius. Or maybe code this way and you'll look 10 years younger. Or how to check your code private at $420, funding secured. And there's no caveat to that. Funding is secured. So I only have 2 goals for this talk. And the hope is that you go away with tools that hopefully increase your code quality and decrease the time taken to code. Also, so before I get to the crux of it, I'd like to provide some context. I also read Sapiens last year. And if you know anyone who's read Sapiens, you think everything is part of human evolution. And we're all sort of, like the book is essentially one giant Soviet Russia meme. It's like, we didn't domesticate wheat. Wheat domesticated us. That's the sort of main theme of the book. So, Homo sapiens, our history has been plagued with a constant battle to procure food. Searching was a large part of it. And then once you found it, you had to do some mechanical work and grab it. And also run away from danger like Triceratops every now and then. And then a few 100,000 years later, depending on who what theory you subscribe to, we found wheat, and it heralded the agricultural revolution, which meant that now we didn't have to search so much. It was mainly about you plant the food, and then you water it, you harvest it, so it's very mechanical. So, it was good in some ways because you didn't have to search so much, so that was less effort. But, population soared as a result because you needed people to work on the farms. And that sort of backfired because then there was a drought and you had this whole big population and there wasn't no food. So food came by easier, so increasing productivity. And then a few thousand years later, we got the tractor. So now to get food, you just had to do some donuts in this thing, and you would basically get some food. So that was an increase in productivity. But you still need to do some mental math, maybe solve traveling salesman kind of to see how you can hit all the farms, with the least amount of distance traveled. And then we got this, and then you didn't have to worry about traveling salesman anymore. That's solved, right? So all the thinky stuff was handled by this, and now you're really productive. So all you had to do was punch a few holes in this thing, and you could get some food. And then, so I was looking for an image of how they did spreadsheets before computer spreadsheets were a thing. So the description is they essentially used pen and pencil to write a whole spreadsheet by hand And if anything changed, you had to rub out the relevant cells and do it again. And then, so, we went, oh, spreadsheets are a great use case. Let's develop software for that. And now you can, just type a few buttons in, and you can buy some celery at the end of the day. So we're super productive now, right? So programming is a very cerebral, very high-level, thinking activity. It's not very mechanical, is it? So can I have a show of hands if anyone has ever, once in their programming career typed? OK, so that's most of the room. 10% of people haven't. You're probably good friends with Jeff Dean then. And I would have liked Jason's tweet, except that he uses Python 2 in his tweets in 2018. So it's a shame. So with Python, there's two ways you can run code. One way is this edit-compile-run-debug mode, which essentially is your standard way of running Python, is you write a script, and then you go Python, and then the name of the script. So you've written up a script, compiled it, run. You find out that nothing works, and then you debug it. And on the other end, you have what's also known as interactive mode for Python. And that's it's essentially a loop of read, evaluate, print. So you'll type something, it'll evaluate it, it'll print the result, and then you move on. No one really codes using the second method, but it's just good for doing quick things like if you want to do some math. So what if you merge the two? What if we could read, evaluate, edit, and then loop? So maybe a reel or a REPL. And that is what I want to show you. So now for the live demo bit. So here we have a script, and I just want to spend a few minutes. Just sort of familiarizing us with VS Code. So this is Visual Studio Code by Microsoft. And here we have a few windows, and let's just fire up and see what happens. So this thing here is a breakpoint. And what's happened so far is we have executed main. So we came here, this was executed, and this is the call stack. So some of you would be familiar with the call stack. When you call a function, it adds it onto the stack, and you sort of keep going. And as you return from functions, you pop them off the stack. So we went into main, and in main, we came into here. And after that, we're in this function here, first three letters. So now, you can also, I'll just go over some features that we come across. So if you hover over, you can see all your variables nicely, and that makes it all very visible. So now, if we wanted to try out, so we just want to return the first three letters of each item in that list. So if I was new to Python, I may try something like this. I just want to try it. I'm not sure whether this would work or not. And when I type it, it says fruits not defined, because you would think, oh, OK, I thought fruits was defined, but you realize that, oh, it's not defined in the scope. So then one might go and try items. And here's one of the things with Python is sometimes you're not sure whether this would grab the first three. Is it inclusive or exclusive? And I blame Rand for this, because Rand is inclusive and everything else isn't. And then you go, oh, OK, so that's two. I think I'm getting closer. And then you might finally try something like this. Oops. And then, oh, you go, OK, that's exactly what I want. So then what you can do is, now that you've tried it out, you can simply just return that and then execute it again. And it'll break again, and then you can just hit continue. Oh, and this is one of the things. This is a issue with VS Code, is if there's list comprehension, it'll keep breaking on that. And there you go. So this allowed me to try out whatever I wanted to see, and then add it to the script, and then execute it. So Another way this comes in handy is the breakpoint. So I've been working with graphs a fair bit at my current job at BVN. So if you want to look at social networks or well, what we're looking at is spatial networks, you often use the network X library. So one thing that has really been helpful in understanding a lot of complex, well, mathematical equations and side of things, as well as the implementation of them, is being able to step through it. So what I've done is I stepped in to the network X library for betweenness centrality, and there I am able to essentially see how betweenness centrality is calculated as per network X's implementation. And this can be very powerful, especially if you're using things in SciPy. So if you want to understand SciPy's version of linear regression, you can just step through the code and understand what linear regression is from a code point of view. And that can be very powerful, because then linear regression isn't this idea that, oh, it's you're minimizing the sum of squared differences. It's actually real code where you can see how it's being calculated. So that's very handy. And the other killer use case for me is when you're using it with Flask. So all you really have to do is kind of have the skeleton of Flask running. Ooh, that's interesting. Oh, it's sort of large here. Oh, this is. Okay. So what's interesting is like when you zoom up this much, you can't see. What if I zoom out? So if you zoom out enough, and I apologize, you can pick your interpreter as well. And I have the virtual environment selected at the moment. So that's also very handy. And it'll come to that. That's sort of part of the setup costs of this thing. OK, so now we're running. And if I were to curl terminal, so let's open another terminal. So let's curl put 5,000. I have a breakpoint set on the get page, and here I am. So return at the moment is none. And I would just like to return something. So why don't we return hello PyCon AU? So currently, ret is still none. And this is where I think VS Code is more powerful than all the other methods of working this way, is that you can actually execute that line there. So that, even though it says none now, if I was to refresh it, this is just one of the shortcomings, is that if I let that run through, it should, did I run it through? Oh, yeah, right, it's in the terminal. So it returns hello PyCon AU. So I was able to just execute things inside the debug console and let it run through, and you get the result that you wanted as if you actually wrote that in the script starting out. And then you can also do some more advanced stuff, like if you wanted to. So this is a common use case for me, is that you would want to say consume some API or see what it returns. Is let's say if we post this, so it's a post request with username to the port that we're running on. So here we are, and let's say if that was, okay, maybe not. So what the nice thing about that is we're able to actually, so we've broken in here, and we can inspect the objects that we have inside here. So Flask has a thing called requests. Some of you may be aware of it. And generally, if you were to use PDB, you would have to type in dir and the object that you want to have a look at, and you can see all the methods on that object. This way, you go, OK, if I'm interested in JSON, I think there's a JSON field. Let me confirm that. So we go, oh, there is a JSON thing. So I can further explore this, and this way, so, oh, OK, so there is JSON. And that way, I can type in, oh, there's a login detected, and return that. And in the terminal, XYZ login detected. So this is a really powerful way to work, because all you have to do is just set up the skeleton, add a few breakpoints, and then write the code that you want to write. And it's also especially useful if you want to do test-driven development. You just write your tests and let your tests call the code that you want to write. And then all you have to do is just break in there and get a version of the code out there that passes the tests. And that can really decrease your time to code. I think that's all I want to. Oh, and also, so here's one more thing I want to show you. Let's take that out for now. You also have a thing called conditional breakpoints. So you can right-click and add a conditional breakpoint. And the condition I have at the moment is if a is greater than 5. So this will only break when a is greater than 5. And this is just classic Fibonacci. So when this turned to 8, it's only then, because it's greater than 5, it's only then that breakpoint broke. So this can be very powerful if you want to look at specific use cases. When if your code only breaks at certain points, you can inspect what's going on when that condition is satisfied. So I think that's another powerful thing, and I believe it's only in VS Code. But please correct me if I'm wrong in the Q&A time. OK, so that was the demo. So use cases. This is really useful when you're dealing with legacy code bases. And it's also, so it's useful in legacy code bases because you might not know exactly what the intention of the author was, hence its legacy. And this allows you a really quick way to explore what's happening and be able to make changes and do what-if cases to see, OK, if I change this, how does it change the output? So the other main use case for this, I found, is when you're using it to teach newcomers to Python and programming for this. Because, so I lectured a course for design students, and Ben and I, who's in the audience, we gave a talk about this on Friday, is students who aren't necessarily coming from STEM backgrounds or have this sort of maybe an innate way of looking at it, or they're at least used to dealing with things in the abstract. This allows a visual method of being able to program. So you know how we saw that if we just hovered over a variable, you could see the value of it at that point. And on the left, you could see all the variables and their values. So that's very powerful when you're new to Python, because then you have this ability to change things on the go and see how that corresponds with the output. And that's very powerful. So what allows us to do this? And to me, it's a little bit black magic. So VS Code uses this library called PTVSD. And it's unfortunate because it sounds like something you'd get off someone else. But it uses a very interesting client-server model. So there's a little Python interpreter that's specific to Microsoft. And it sends the server whatever's being executed, and it returns back the corresponding actions. So I think that's where I wasn't able to do too much of a deep dive into what the code looks like, but it's a thing unto itself. And it was also part of Visual Studio's Community Edition. That's where I sort of was introduced to this way of programming. And then when VS Code came out, it was just a lot more powerful, a lot more self-contained. So downsides. Setup costs. And this is the main barrier, because I think it's an excellent way to teach programming using this kind of interface. But you need to be aware of essentially where your Python is installed, which interpreter you're targeting. And as sort of Grant mentioned, that there's a lot of just random things that occur. So if you, for example, execute with Command and Enter by accident in your debug console, it'll fire up the terminal with Python. There's a lot of weird things like that that will catch you if you're not aware of that underlying sort of architecture that it sits on. So unfortunately, there's still a fair bit of setup costs in getting this working. There's also a performance penalty, and that's primarily because of the server-client model. And it often makes it not so good when you're dealing with very sort of intense or long-running processes. For example, traveling salesman. If your bug occurs after a bunch of, say, double nested loops, it just takes a while to get there. And also, not all features are supported. So if you were to go off and try a list comprehension in the debug console, sometimes it doesn't recognize that the thing you're iterating over is defined. OK, so that was VS Code. I just wanted to quickly talk about some non-VS Code options, mainly PDB, good old PDB. And a lot of you may be aware of this line that you had to type in, which is gone now, thankfully, because every time I had to do it, you have to Google. It's like, oh, what was that command again? So in Python 3.7, that line has been replaced by breakpoint. So all you have to do is type in breakpoint if you're using 3.7, and it does the exact same thing. So with our previous example, if I were to run that, it breaks right there. And there you can list. So this is just after that breakpoint, so you can see where it's broken. And there's a couple of things I just wanted to show here while we're here. So you can somewhat replicate. The functionality here. So what I've done there is I've said display A. So print whenever A has changed. So if we were to continue stepping through, so A has been updated to 1, and you get a nice little output there, and that can be very handy when you're debugging things. Another thing, so one of the limitations of PDB is that you can't do multi-line statements, because whenever you hit enter, it sort of doesn't work. So another alternative is you can do interact. So when you type in interact, it creates a Python interpreter, or in interactive mode down there, and there you can go off and make changes. So, but one of the shortcomings is that if you make any updates to variables, they don't carry over when you quit out. So it's a little bit of getting used to. There's other alternatives out there that you can use. When I gave a version of this talk at SciPy, someone came up and said that you can use Spider. And Spider, I believe, comes bundled in the Windows version of Python. So that's handy. And when I sort of experimented with it briefly, I don't think you can do multi-line statements in the debug console, which you can do with VS Code. There's also PyCharm, and I think that's great. It's, in my experience, a little bit bulky and a little bit expensive, as in not free. And similarly with Komodo, you have to pay for that, but I believe you can do the same thing there. So in summary, there exist methods that allow you to logically step through code, so you don't necessarily need to litter your code with print statements and then take them out. Python lends itself well to exploratory programming, which is the idea that you break at a certain point. You don't exactly know how you're going to solve it, so you try out several methods. You experiment rapidly and just keep the things that work. And also that history plays a big role in how we do things. And that's primarily, I think, the reason why we're still stuck in using this method of programming, which is just you type a script, you run it, you see it doesn't work, then you go back and type it again. And it's sort of everywhere. Like the reason we have broadsheet newspapers today is because in 1712, some government decided that there's going to be a tax per page for newspapers. So they said, OK, well, why don't we just increase the size of the pages? So I think we need to be aware of that so we can be free from those, free from that historical baggage. Thank you.
Thanks, Ishaan. So Ishaan's happy to take questions at the moment.
And comments and heckles.
end comments, all of that. I may break things if we get a little off track, so we'll see how we go, but I'm sure we'll be fine. We've got a little bit more than 5 minutes to do that, so we've got a little bit of time. We've got one question at the back. Just if you can wait for me to bring the mic, that'd be great.
Hi, thanks for your talk, and I also really loved your talk on Friday. In our development environment, we use a virtual machine for our Python, to run our Python. Would I be able to connect the VS Code debugger into the virtual machine? You mentioned there's a client-server model. Do you know anything about that?
Right. That's a good question. So I think you can run PTVSD, if I'm saying that correctly, by itself. And because what actually happens is it runs that process, PTVSD, and the electron is another process, which then talks to that process using sort of the local network interface. So I'm pretty sure you could do that if you expose it on your VM. It'd be interesting if you could just run your VS Code outside and configure it such that it talks to that specific port. I'm pretty sure it's possible.
Did I see one over here? Yep.
Hi, yeah, thanks for the talk. In Visual Studio Code, if you search for Python, there are literally dozens or maybe even hundreds of Python plugins. Is it just the Microsoft plugin that you've installed, or is there more that you need to install to get that working?
So this is just the so previously this was someone's open source project, which was then absorbed by Microsoft. I wish I remember that person's name. Shout out to them because I think it's a great library. And they were then hired by Microsoft to maintain this extension. So what you see there is just the Microsoft's sort of Python extension. It comes with everything included.
Other questions? Yep.
Thanks for the talk anyway. For somebody who's new to VS Code, can you show us how do you set up that layout, and is it all comes up when you load Python, or do you need to set these things up? Thank you.
Sure. So the main process is really just installing the extension, and there's a extensions thing here. You just type in Python, and you install it, and from there on, it's if your setup is quite standard, by just sort of adding the configuration and typing in Python, it should work for 80% of cases. Having done this with the Code 1161, the design computing students, it basically worked most of the time, except maybe like 10% of the time when someone didn't have Python in their path or it wasn't in the right place. That's when it broke. But if you have a standard environment, it should all just work out of the box with the default configurations.
Other questions? I have one, just really quickly. One of the things around VS Code and Python that I've found, as I mentioned at the beginning, is it's very hard to find really good solid tutorials on how to set up the environment, because if you do I did have a non-standard environment, so none of this was working for me. Do you have any kind of go-to resources or good blogs that you would recommend?
That's a good question. I found there's quite a few videos. So VS Code's taken over as the most popular editor as per Stack Overflow's latest developer survey. And in my experience, there's a few good videos that allow you to set it up with the standard environment. For the non-standard environments, it's really, I think, about just understanding that configuration file and knowing what means what, essentially. And the documentation has improved significantly for VS Code, especially when it was absorbed by Microsoft. So I think it's probably your best bet is the documentation for this.
Anything further from you guys? No? Great. I'd like to thank Ishaan again.
Thank you.
And,